Dennis Houghton again from Eddy County Extension Office, and I'm sitting in our break room kind of, and we always have coffee on, so if you ever want to come by and just sit and visit and have some coffee, we're always willing to do that. But usually this is also where I talk with farmers about their fertility and the results of the soil samples. Last time we went out and took soil samples in an orchard and in a yard, and I got Mr. Blenden's permission to use his soil sample. So we'll kind of go through, now that you got this piece of paper back in the mail, what does it mean and how do you use it? Because it doesn't, I mean, it's like a lot of information. If you don't know how to use it, it doesn't do you any good. So let's go through the soil sample, and I'm going to use a red pen here. And it's going to start off with, up here at the top, it's going to tell you that you got Eddy County, and that's in reference because we use that to go back to the NRCS soil surveys. It's going to have the client's name and address, and I probably want to, well, that's his work address, so that's okay. And record, and then we'll have number of acres. Now we took an estimate on Mr. Blenden's field. I actually measured that. That's real easy to do. You just to measure your yard and know how big it is, and he has a quarter of an acre in his front there. Irrigation, we put down that we're going to irrigate about 36 inches, which is about average for a field here. You know, the dates here, the planter's name is not in here. That should have my name in there, but I didn't put it in there. So, and we put has buffalo grass last year and wants to have it again this year, so it's a continual perennial crop. And here's the sample ID number. This is the lab number. This is assigned by the lab when we have the analysis done, and it tells us what the pH is. The pH is 7.5, which is a good pH for Eddy County. A lot of times we're getting a lot closer to 8. The higher the pH, the greater the alkalinity. The lower the pH, the greater the acidity. And we don't have any acid soils I know of in Eddy County, but we do get some that are about 7.2, 7.3, which aren't too bad. Okay, electroconductivity, and that's actual the measuring of conducts of electricity through the soil in a saturated paste. Now, a lot of people know about resistance, and you have a volt-ohmmeter to measure resistance. Well, just if you spell that backwards, that's millimoles. And so conductivity is measured in, the opposite of resistance is measured in millimoles. And that's a measurement of the salt, because pure water has no conductivity at all. Pure distilled water, the conductivity is 0. And as you add salts or other impure impurities to water, the conductance goes up. And so electroconductivity is a measurement of the salt, and 0.89 is a good low measurement. Anything above 1 or 2 we start really worrying about. The soil texture is a loamy sand, and that just tells us how much particle sizes, what the percentage of different particle sizes there are. So there's this fairly large coarse soil, and clays are real fine soils and have smaller particles. The organic matter is 1.2%, which is really excellent for Eddy County. A lot of times I see it less than 1%. Ideal is about 2 to 3%, but that's in Ohio, you know, where they have soil. The next measurement is in nitrogen in parts per million. That's 1.9 parts per million. When you calculate that out, that tells you have 40 pounds of nitrogen per acre. Phosphorus is the next number. It tells us we have 23.2 parts per million, which is equivalent to 110 pounds of phosphorus per acre. Potassium, which is potash, we have 30 parts per million, which is equivalent to 75 pounds per acre. Magnesium is 3.0, which is 19 pounds per acre. Calcium is 5.6, which is 58 pounds. And this is the pounds per acre and parts per million up here on top. Then we come down here, our yield goal, and we just put 5 tons to the acre because that's kind of what we want with a lawn. You don't realize it when you're out there mowing that lawn every week, but the average lawn homeowner mows about 5 tons of acre off his lawn, which is another issue about going into our landfill, but we'll talk about composting on another day. And I really support composting because it does that. Then you look at these bars across here, and they're not relative to each other. You got to look at each one individually, because there's no relationship between this one, which is very low, and this one, which is high, but it's each individual in parts per million, and because of the scale, we have to do it that way. So we're really low in nitrogen. Our phosphorus is very high on this soil. Our potassium is moderate. Our magnesium is very low. So if we have pecan trees or trees that require a lot of magnesium, we know we're going to have to put a lot of magnesium out there. Calcium is very low. That's good, because calcium and sodium together make salt. Okay? And iron is moderate, and zinc is very high. So if we had a pecan tree, we wouldn't have to be doing a lot of zinc work on that one. So that just gives us an idea. Now we get down to the meat of what's in a soil sample recommendation. And this is the nutrient recommendations right down here. And that's telling us to produce this amount of grass, we need to put 150 pounds of nitrogen per acre. Now, we'll talk about how to figure that out in your fertilizer here in a moment. We don't need to put any phosphorus out, and we need about 40 pounds of potash and about 2.5 pounds of iron in this case. Okay, we don't have any. We didn't measure the irrigation. That's city water, so we didn't we don't have any irrigation credits for having nitrates in the water, because our water from CID or other places have some nitrogen in it and have some nutrients in it. We always sample that for farms and determine if there's anything else. And then other nutrient sources. We didn't put out any manures. We didn't put out. We didn't plow up any alfalfa that we plowed back into the soil. So there's nothing there. So then we come down here to the very bottom, and it says EC very low, no limitations, so that we don't have any problems with salt here. We don't make any recommendations for gypsum because there's no problems with salt. And I got another soil sample from the country club. I'll go out there, and it's a little bit different than this one. Suggested fertilizer is 333 pounds per acre, or for a 45% nitrogen or urea. 91.8 pounds is what's totally needed, and we take that and divide that basically by 4, because we had 1/4 of an acre, and that tells us about 991 pounds is what he needs on that field. When we started with Dick, he had to put 700 pounds of nitrogen on his grass first year, and now 3 years later, through careful nutrient management, blending the product to match his soil, and only fertilizing what he needs, we're down to a maintenance load, which is this about how much nitrogen is taken off every year by that 5 tons of grass that he's cutting with his lawnmower. So we're in a nice balance here. We don't have to build that soil up anymore. We just have to replenish what is taken off by removal of the crop. And we don't ever think of grass as a crop, but it's basically a crop because we're growing it, we're cutting it, and then we're putting it somewhere else. My case, at my house, I feed it to my sheep. They mulch it, return it back as another form of fertilizer, and it's returned back to the yard. A little bit different fertilizer, but most people don't have that opportunity. So, and then we have the total blend is 399 pounds. So we might as well say 400 pounds because it's going to come in 500 pound sacks. And the blend cost, this blend cost is pretty old and obsolete because fertilizers are changing and have gone up. This is a 10-year average, and the price of fertilizer this last 3 years has more than tripled. Where we were buying ammonium sulfate for $127 to $180 a ton, For farms, now we're paying close to $600 a ton. So the price of fertilizers, so don't pay much attention to this because it's on a 10-year average, and the last 3 years the price of fertilizer has just been outrageous, you know. So then we go down here, and we need 66 pounds of muriate of potash, and has a total blend, and that's how you read your soil sample. A lot of people, you know, now you don't have to use this 45% urea. You can use ammonium sulfate, but ammonium sulfate, when you look at a fertilizer bag, it has 3 numbers on it. It's going to have ammonium sulfate. It's going to have 240024. Another fertilizer we use a lot is going to be 1154O, or a muriate of potash is going to be 0060. This first number is nitrogen, the second number is phosphorus, the third number is potassium, and if there's a fourth number, that's sulfur. And so with ammonium sulfate, it's 24 units per 100 pounds. There's 24 pounds of nitrogen. And there's also, out of that 100 pounds, there's another 24 pounds of sulfate. So out of that 100 pounds of ammonium sulfate, we're getting roughly 50 pounds of nitrogen and sulfur. And the other 50 pounds can be made up of a lot of different material. You know, out of a fertilizer that's 1154O, this has 11 pounds per 100 pounds, has 11 pounds of nitrogen, 54 pounds of phosphorus, and then we go out there and it has a lot of other different products. And muriate of potash is 0, no nitrogen, no phosphorus, and 60 pounds of potash per 100 pounds. So some people that are mathematically inclined, you can calculate out how much product you need by using different, and what it costs you per unit of nitrogen versus using a 240024, which is ammonium sulfate, or using a 4800, which is urea. Okay, and we'll do that here in a moment. I'm going to take a break and get a cup of coffee and set up a blackboard, and I'll show you how to do that calculation. All right, we'll be back here in just a moment. Now that we've filled up on coffee, we've gone to the bathroom and all that good stuff, let's go back and review what we just talked about. One was all fertilizer bags will have at least 3 numbers on it. That'll be like 11, 10, 10. Do you remember what those numbers mean? 11 is nitrogen, 10 is phosphorus, and this 10 is potash or potassium. So how do we figure out, you know, one of the first things when I deal with farmers is to say, how big is that field? And they'll tell me that's 3.9 acres or that's 16.5 acres. They'll know, but do you know how big your yard is? And it's real simple. Your yard, length times width, equals number of square feet. Okay? And so you just, if you're 40 feet by 40 feet, that's 80 square feet. I mean 120 square feet. I need to get my calculator out here to keep me straight. So I'm in front of the camera, I get nervous and can't think. Okay? And so it's real simple. But what if you don't have what if your yard's shaped like that? Well, just come in here and break this out, measure this one, figure out that, figure out the area for that, and add them together. Or if it's a triangle, you just figure out the distance for a triangle and add them together. And that'll give you the total number of square feet. And it doesn't have to be exact, but plus or minus, 5 or 6 square feet's a good calculation. So we've talked about what's in the bag. We talked about some examples of different things. We've read the soil sample, and so let's take and do a couple examples here. And let's say the soil analysis for your garden, a vegetable garden, says you need 3 pounds of N. Okay, I'm back up here and put need. Well, my mother never said I had good handwriting. So we need 3 pounds of nitrogen based on our soil sample. We need 1.5 pounds of P2O5, which is phosphorus. Okay, and let's say on an average garden we probably need at least 1 pound of potash, K2O, or potash. Okay, so that's what we need. I'll take the 2O off. So how do we calculate out how to mix that all up? I'll switch over here to a blue pencil just so you can see the difference. And it's really pretty simple. We need, in your garden, we want to look at a fertilizer bag. We kind of look at this, and we got 3 parts to 1 part to 1 part. And so with 3, 1, 1, so a fertilizer bag that has 3 parts to 1 to 1 is something that we're going to look at, and a common one that you find in garden stores is going to be 16-8-8. Okay, it's not quite, because we need a little bit more phosphorus than we would get directly, so we'll just, when we do the calculation, we'll just take that into account. You can't get anything exactly the way you want it. And everybody says, well, why don't they just make 100% nitrogen fertilizer? Well, God made these minerals and nutrients, and we got to take it the way He gives it to us, and the way it comes out, and what binds, and physical properties. So we end up having to use the way it comes out. Let's say your garden is 75 feet by 10 feet. So you're going to build you got a garden that's 75 feet by 10 feet. That's a pretty nice garden. All right, 10. So how many square feet is that? You remember that? 75 times 10 is 750 square feet. Right? And so how much fertilizer do we need at 1688 to get to this number right here? So how do we do this? 75 by 10 is 750 square feet. We want 3 pounds of N, and we divide that because our fertilizer has 16, so we divide that by 0.16, or 16 units per 100, or 16%. Okay, and that will give us, 3 divided by 0.16 will give us 18 point, I'm just working off the top of my head here, about 18 3/4, something like that, 18.75 pounds. And then we have 750 square feet, and this is per 1,000 square feet. So we take 18.75 and multiply that point by 0.75 to get it into thousands of square feet. And that comes out to 18 times 0.75. It's going to be less than that. It's going to be roughly about 14 pounds. Somewhere between 14 and 15 pounds. And I think if you use a calculator, you'd probably be more accurate than I am right now. But so you want to put 14 to 15 pounds of 16.88 on your 750 square foot garden. And that's how you calculate that out. So you don't need to put out 25 pounds or 50 pounds, whatever it's in a sack. You can, I weigh mine on a little bathroom scale. Just stand on it and weigh it. Or you can, roughly a 3-pound coffee can be plus or minus 3 pounds. And you can do it that way. And spread it out evenly and do that. So that's for a garden. Okay, let's go back and let's talk about a lawn. For that's where most fertilizer is used. And a soil recommendation, we got our soil test back from the university, and it says we need 6 pounds of nitrogen, and we need 2 pounds P2O5, and it said we were sufficient in potash, so we didn't need any potash. And one thing I run into here, because we have potash miners here in town, is either it's very high in potash or no potash. So it depends on if they work out the mine or not, you know. So this is a potash miner's field, and lawn, and he's put plenty of potash on it, but he didn't put enough nitrogen and phosphorus. And so, how big is the lawn? The average lawn in Carlsbad is roughly, front lawn is roughly about 110 feet by 22 feet, and then there's a driveway, and then there's another section. So we're just going to figure out for that one part, 110 by 22 feet. So 110, 22 times 110 is roughly 2402. You know, 2 times 0 is 2 times 1 is 2, 2 times 1 is 2. Yeah, 2,402 square feet. And so, how much do we need to do? So, 6 pounds of nitrogen, we're going to use a fertilizer that's a 16, 8 again, the same one that we use in our garden, because we bought a 50-pound bag for the garden, and we only used how many pounds, you know, a few pounds of it, half of it. So we still got this fertilizer, so we might as well use it up, right? Right. Because we don't, you know, there's no point in storing that stuff. Okay, so we're going to use 1688, so we need 6 pounds. Right up here, we take this number, and we bring it down here, we need 6 pounds. We bring this number to 1688 and multiply by 0.16, and that equals 0.16. We need 37.5 pounds of 1688 fertilizer per 1,000 square feet. Okay, so how many square feet do we got? We got 2,402 square feet. So we take 37.5 times 2,402 square feet, and that equals I don't know. Have to figure this out. 2,000 square feet times 37.5 per 1,000, so it's going to be 60, roughly 74 pounds for 4,000. I mean for 2,000 plus another little bit, so it's going to be roughly 80 pounds of 1688 for that lawn. Which, when we add that to our garden, that gives us 100 pounds that we need to buy for our garden. Okay, that's great for nitrogen, but what about this number? What about our PTO5 number? Well, we do the same calculations, except for we use the 8 instead of the 16, and we use the 2 instead of the 6. And so to do that, we go back, it's 2 times 0.8, right? 8%. 0.08, 2 times that, and that equals 25. So we need 25 pounds of PTO5, right? So we take 25 times 2.042 if you used a calculator instead of just doing it over your head and coming up with 25, because I'm using a cheat sheet right now. And that equals 51 pounds of PTO5 per 1,000 square feet. And so we got, how many square feet did we have? 2,402. 2402. And we need 50 pounds, well, 1 times 51. There's an easy way to do this if you think about it. 51 pounds per 1,000. And we want to know how many X number per 2,402. 2,042. Cross multiply 51 times 2,042 and divide by 1,000, and that's going to give you roughly 3.12 pounds. Okay, so don't need nearly as much PTO5. We go back and look, calculate out how much we put out if we did for nitrogen, and we're going to meet our PTO5 requirement. It's going to be slightly higher than that, but there's nothing you can do about that. You just have to go with it. So, what do you do? And it's spring, you didn't take a soil sample. What do you do if you don't have a soil sample? Well, guess. Okay? Or you can look on the fertilizer bag and it'll tell you how much per 1,000 square feet to put out. You know, 10 pounds per 1,000 square feet. You still have to know how many square feet you have in your yard and be able to do that ratio. It's 10 per 1,000, and I got 2,000 square feet. 10 times 2 divided by 1,000 is 20 pounds. Okay, I did that one easy so I wouldn't have to think very hard. But, or you know, there's also tables out there for crops, and if we use a standard alfalfa, a standard table for a moderate Bermuda grass table value, it tells us how much nutrients are needed per yield required. So if we're working with alfalfa producers, that's easy. I got a table in there that will tell me how much phosphorus. It takes 80 pounds of phosphorus per ton of hay. It takes 120 pounds of potash per ton of hay. That's pretty easy. So if I want to make 8 tons of hay, I just multiply that out, and that tells me how much I have to put on there if my soil is sufficient to start with. You know, and if I multiply that out, and my soil sample says I have 120 pounds per acre, and I need to have 300 pounds, I can subtract that, and 0 from 0, 0, 8, 1 over 2, so 180 pounds of all the fertilizer I need to add to have enough out there for this year's crop. Does that make any sense to anybody? If not, come on by the office and I'll sit down, drink a cup of coffee, and visit with you, and hopefully I'll be able to explain it to you on a one-on-one basis than I did here. But I think this gives you a general idea that there's a couple things you need to know when you're getting ready to fertilize your yard. You need to know what you need, so you have to have a soil sample. And you don't have to take that every year. I do soil samples about every 5 years, like with Mr. Blendon. I did his soil sample every year for the last 3 because we started off in a very poor soil and we built it back up to where it needs to be. So now we won't sample but every 5 years, you know, and see if we're still on track. So you need to know what you need. And you're going to get that from either soil sample or a table value, or you're just going to work off the fertilizer bag. Now remember, it's kind of like coffee. If you read on the can of coffee how much grounds of coffee, you'd make awful stout coffee if you made it the way they told you to. They're in the business of selling coffee. The fertilizer guy in the bag is in the business of selling your fertilizer. So he's going to give you the maximum recommended dose is going to be on that fertilizer bag. And usually you can go under that. You need that. Okay? What else do you need? You need to know how big is your yard. Application site. For homeowners, that's in square feet. For farmers, that's in acres. Okay? And from that, you can calculate out how much fertilizer you need to buy so you don't buy too much, too little, and you get what you need to. You can also compare prices. I mean, this is a big deal because the price of fertilizer is so high right now. I just sat down with a farmer last week, and we were able to save him almost $12,000 on his farm because we were using versus what he'd used if he'd used one fertilizer versus another type of fertilizer to supply the same nutrients, just based on what the price of it is. So when you go to the store and you see that bag of fertilizer that is 24.00 and it costs you $10 for a 50-pound bag, or $5. Well, you just figure out it costs you $10 for that for a 50-pound bag. So it's costing you $20 per 48 pounds of nutrients. And then you also see another bag in there that's 48.00, that's urea, and it's $32 for a 50-pound bag, or $64 per, no, sorry about that, let me back up again. 48,880, and it's $32 for a 50-pound bag. That comes out for 48 pounds of nutrients. That comes out to 64 pounds to 100 pounds to get that 48 nutrients. You're better off buying 4 bags of ammonium sulfate at $20 than you are the higher percentage, and it can be vice versa. So pay attention, know what your percentage of active ingredients are, and there are some differences between urea and ammonium sulfate. For the homeowner, that probably doesn't mean much, but to a farmer, we look at salt indexes and a lot of other things because we're putting a lot more material out there than most homeowners. So I hope that's a good deal. Let's call it a day today. Go out there and get our soil samples and go down to the local garden store or the fertilizer store and purchase the fertilizer that we need. And don't overspend. Don't buy too much. Because one of the things that happens when you put out too much fertilizer on your yard and you water is where's that fertilizer going to go? It's either going to leach into the groundwater or it's going to run off into the river. If it runs off in the river, that promotes golden algae blooms and fish kills. If it leaches down into our groundwater, that creates nitrates in our groundwater. Nitrates cause blue baby syndrome on children, and we don't want either one of those things to happen. So be a good steward of your resources. Figure out what you need. Don't put out any more than what you need. And with that, we'll see you next time. This is Woods Houghton with Eddy County Extension Office. Thank you for listening.